If you are a front-end engineer or you're interviewing to be a front-end engineer, you might have been asked this question before in your interviews. It's a very common interview question, particularly for front-end engineers, that gauges a wide breadth of knowledge. All right, so let's get into it. What's this question? So let's say I give you a function that's supposed to mock API data that you get back from a fetch request. This function just returns a list of fruits for you, and it filters based on a passed-in query. So I want you to have an autocomplete input and also display the results of calling that function with whatever the user passes into that input. So basically, I want you to build an autocomplete. So let's take a quick look at the code. Here we have a function get autocomplete results, and it takes in a query and returns a promise. And so we have an array of fruits here. It's not great, but I put a bunch of fruits, and then I'm returning a new promise, and I'm setting a timeout to be a random number. This is supposed to mock slow API requests, so this can be any random number. And in this timeout, we call resolve, and it's a very simple function. We're just filtering on the fruits, and we're saying if that fruit, lowercase, has the query lowercase, then we're gonna return those fruits. Now, if you scroll down here, this is what the actual component does. I use Tailwind here, so don't get too stressed out about that. We have basically an input, and then we have a container div that shows the results. And if you take a look at what this looks like, it just looks like this. So here is an input that you can enter in whatever you want, and then this is where your results are supposed to show up based on your input value. Let's break this question down a little bit to make it a little bit easier for us. So what do we have to do? Well, first, we're going to have to track in the input value. Whatever the user enters, we're going to have to track that somehow and keep it in state somewhere. Secondly, we're going to actually have to call that function, this get autocomplete results, and we're going to have to store the data that it gives back in some way too. And then we're going to have to show that data right here in this div. Pretty simple, so let's just implement what I said. So inputs take in a value and an on change. So here we can have a value and an on change. So an easy way to keep track of state in this React application that we're working in is to use state. So here we're going to just create a, and Copilot is very graciously helping me here. We're going to create a query and a set query and just set that to use state with an empty string for now. In this value, we're going to pass in that query. And in this onChange handler, we're going to pass in a function that will get called whenever this input gets changed. So this function takes an event, and we're basically going to call setQuery, which sets the query to the new value that the user has inputted. So here we're going to call setQuery, and E is an event on the input element. So how you can grab this value is you can do e.target.value. And now just to test that this code works, we're just going to console.log out the query. Cool. Now if we look at our website, here I'll type in Apple, and as you can see in my console, it's printing out each time that I change a character in this input. If I delete a character, it will also call this function. All right, awesome. So now we set up a way to keep track of input changes that the user has made. We're going to use a use effect and something called an instantly invoked function expression. So let's take a look at what this use effect is going to do. Since we're calling a function that returns a promise up here, so this get autocomplete results returns a promise, we need to wrap whatever function awaits that call in an asynchronous function. Now, use effect can't be asynchronous. So what I'm going to use is something called an instantly invoked function expression. So long phrase for basically a function that's immediately called as soon as you define it. So how does that look? Well, here we're going to have an async function, and we're just going to call it. Simple as that. Looks complicated? Not that complicated. So now in this, we can now await that function. So we're going to say data is equal to get autocomplete results, and we're going to pass in this query. Now, whatever the results of this are is going to be data, but I did something wrong. You can see that data is a promise, so what you're going to have to do is await. And now data comes back as an array of strings. So there's one thing that we missed here too. Query can sometimes be empty, and you don't really want to call this function with an empty string. So what we're going to do is basically just run a check that if query is an empty string, we're just going to return. So now we have this data, and what do we do with it? Well, similarly to how we tracked our query in a state, we're also going to keep track of the data that we receive back in a state. So here we'll just call it suggestions and set suggestions. And we're going to just use state, and I'm going to type this as a string array. initially it'll be an empty array. So now when we get this data from this function, we're just going to set the suggestions to that data. I don't know why my editor isn't yelling at me, but there's something wrong with this use effect. We use query, but we don't keep it in our array of dependencies here in our use effect. So we're going to have to put that in there. Basically, what putting query in this array means is that anytime query changes, this use effect will run, which is what you want it to do. When I had it to be empty, it only ran the first time and didn't run again after that. So here I'm just adding query, so it would re-render each time. So now all that's left to do is show these results. So here we're going to do something really fun. We're just going to map across our suggestions, grab each suggestion, and then just put it in a div. Awesome. And now let's take a look at what this all looks like. Now, if you come here, I remember that I had a bunch of berries in my array of fruits. So I'm going to type in berry. And look at that. It's showing everything that has berry. But I don't know if you noticed something a little wonky. Let me zoom in here. And let me type berry again really fast. Did you see something show up and flicker away? Let's type it a little slower now. Did you see that flicker on the bottom too? So there's a couple of issues with this implementation. Let's come back here and do something real quick. Let's console log every time we make a query. So if I come back here and type berry, as you can see, it makes a call for each character that we type. Sometimes what happens is the data for the query with BE sometimes returns after the query with the data BERR. So what that means is that's when you see that flicker happening. So what the front end is doing is it's getting one set of data back, and then it's getting an old set of data, and then it doesn't know which one to show. So it shows both real quick. We also have a bug here where it says each child on the list should have a unique key prop. So since I know that all the items in my array are unique, I will use that as my key. But for example, if you're doing this in a real world scenario when you have an API, most things have an ID associated with them. So you could just key each item with their ID. For here, I'm just going to use their name suggestion, so which is just the name of the fruit. There was also another bug if you didn't notice. Here I typed in berry again, and let's say I just fully remove berry. The list still stays populated. If you go back in our use effect, when we check that there isn't a query, we just automatically return. What we want to do before we return is just set our suggestions back to an empty array. This will basically mean we cleared it. There's other ways you can do this. You can do this outside of the if statement, so you can just set suggestions to empty in the beginning. And what you can do is instead of this if, you can just wrap the whole thing in an if, saying if the query.length is greater than 0, basically meaning if there is characters in that string, then call all this data. So you would just get rid of this and wrap this all in this if statement. Whatever you want to do. Now, if we come back here and type berry and we remove it, it'll go away. Perfect. So now let's take a look at a couple ways that we can improve this experience for the end user. So when I type in berry extremely fast, I don't care what the results for B, what the results for BE, what the results for BER, what any of those results are. I care about berry. So what we can do is this technique called debouncing. In front-end programming, debouncing a value refers to the process of delaying the execution of a function, or basically setting a value only until a certain amount of time has passed since the last time that value was updated. If a user is typing super quickly, you want the function to avoid being called too frequently. So the purpose of that is to avoid that flickering that we saw earlier. And it also improves the overall performance of the app since we don't have to make a request for every single query that gets typed in. We only make a request for something after a sufficient amount of time has passed since the user has last inputted in something. So the idea is instead of using this query that the user has inputted directly into this function, we're going to pass it a debounced value instead. Let's create a custom hook to get a debounced value. Here we're going to create a use debounce value hook. And this hook is going to take in a value, which in this case is a string, and it's also going to take a time. And a time is basically a threshold. It's the amount of time to wait before giving the value back. So for now, I'm going to make the time to 50, and this is going to be in milliseconds. In this debounce value function, we also want to keep track of the current debounce value in a state. So we're going to set debounce value and set debounce value. And this is going to be a use state, and the initial state of this is going to be the value that you pass in. Now, a typical way to implement debouncing is to use a timeout. So we're going to create a use effect. And in this use effect, we're going to create a timeout. Timeout takes in two arguments. One is the actual function that runs after this timeout has occurred, and the time. So the time is going to be just the time that's passed in. In this function, we're basically going to set the debounce value to the value being passed in. Since we're using value here, we're going to have to depend on it in our dependency array, so I'm going to put value in there. Now, when you use timeouts in a use effect, you definitely want to clean them up after the use effect has run. So we're going to have a cleanup function here. And in here, we're just going to call clear timeout and pass in our timeout. I also forgot, we are also relying on time here. So if time ever changes, we also want to rerun this use effect. So I'm going to also pass in time. At the end of all this, I'm just going to return the debounce value. So how does this work, you ask? Well, we're initially setting this debounce value to the value being passed in. We run this use effect every time value changes, which means we are going to reset the debounce value to the new value that's being passed in, but we're only going to do it after 250 milliseconds if the value hasn't changed again. And now, how do I keep track of if the value has changed or not? It's with this clear timeout. Whenever the value changes in a use effect, or whenever something in the dependency array changes in a use effect, it's going to clean up the previous effect and start a new one, right? There's probably a better way to explain this, but the idea is that it will actually clear this timeout. If you look at the React beta docs under use effect, you can take a look at what the cleanup function does and the lifecycle of use effects, hooks, etc. So you can see what happens and when they run. So that's our hook use debounce value. Well, we come back down here and we call it. So we know that we return a debounce value. So we're just going to say debounce value is equal to use debounce value, and we're going to pass in this query that the user sets. And now down here, instead of passing in query to this, we're going to pass in the debounce value. I'm actually going to call this the debounce query just to keep the terminology the same so it's not confusing. So let me go ahead and call this debounce query. And we also want to, instead of checking the query length, we want to check the debounce query length. And now to test it, I'm just going to console log the debounce query. And I'm also going to pass it in down here. And now I'm going to type in Barry as fast as I can. Wow, look at that. Did you see that? It only showed me the last result. If you're anything like me and you have like 120 words per minute that you can type, this is really useful. So yeah, there you go. That's debounce value. That's one way to solve this and make this a better autocomplete. And why is this important? Well, you can see that the flicker kind of stops because we don't run that function every single time the input changes. We don't have to run a query on queries that we don't care about. We only run it on the most recent one. And this also prevents our server from being destroyed by crazy amount of requests. So it helps cut that down. So let's talk about something else. Do you remember our function for getting the autocomplete responses? I have this random timeout that makes it so that sometimes this call takes longer and sometimes it's really quick. So what happens in the case where you ask for BE, wait a little bit, and then add RRY, but the result for BE comes after the result for BERRY? I managed to actually get the state into a spot where one promise ended up completing after another promise. So here we have cucumber in the results, but the query is berry. And this would work if we typed in BER, but not if we type in berry, right? Because we're just doing a filter. We're just saying, does this string contain this other string? So this is a case where an abort controller would come in super handy. You want to use something like an abort controller or a Boolean flag. What that basically does is you can cancel the previous promise. So the input in that case was berry, but the promise for BE came back after the promise for berry, which means that was the result that was shown in the UI. If we look at the fetch docs in MDN, fetch takes in a URL and some options. And one of those options is a signal. And this signal basically lets you communicate with the fetch request and abort it via an abort controller. We're not using fetch since I mocked our data with the function, but we can similarly use something like an abort controller, but it will just require me changing our function a little bit. So now our get autocomplete results function will take in a signal, which is an abort signal. And what it's going to do is basically, if this signal is aborted, then we're going to reject this promise and not resolve it. Let's go take a look at the code for how to do this. So what we're going to want to do is create a controller just in the base of our component with new abort controller and set that to controller. And now this is a controller object, and this will let you abort these requests whenever you want to. In our use effect, we want to grab the signal of this controller. So we're going to grab it using controller.signal. And if we look at the docs, the signal is basically a read-only property that tells you whether or not to abort a request. Up here in our function, when we take in signal, we're just checking to see if it is aborted, and we're just going to reject that promise if it is, right? So we have the signal here. And now we have our function, and we're going to want to pass that signal along into our function. Here comes the part that might be a little confusing. So in our cleanup function to this use effect, I'm going to want to abort this controller, and I'm going to pass in the reason cancel request, just so it doesn't yell at me in the console in Google Chrome. Why do we call abort in the cleanup function to a use effect? So this function, this cleanup function, gets called whenever the component using this hook, this use effect hook, gets unmounted, or if the effect reruns because debounce query changes. Since it gets called when the component is unmounted, that basically means the component is no longer being rendered. So we don't need the results of whatever that fetch call, or in this case, this function call, is going to return. And so the other reason is that when debounce query changes, we have a new set of data that we're trying to fetch. So whatever previous fetch requests we have, we should terminate those. So that basically means if we made a request for BE sometime in the past, and we then made a request for Barry, then we want to just cancel BE, even if it's in progress still. This helps the performance of the application, basically. I mentioned earlier, similarly to an abort controller, you could just use a Boolean flag. And really quick, let me show you what that would look like. For example, let's say our function here doesn't take in the signal. To basically mock the idea of an abort controller, what we can do is here we can just set a flag, ignore, equal to false. Here, in this if, when we are setting the suggestions data to this new data, if you don't want to ignore it, then you'd want to set it. So similarly to how we were setting abort earlier in here, we just want to set ignore equal to true. We basically want to set a flag ignore to false in the beginning here. And if we don't want to ignore this, then we're going to actually update our data with the data that's coming back from this function call. And then in our cleanup, we're going to set ignore to true. So this is basically setting that similar aborted flag. We're saying ignore this fetch or don't ignore this fetch. So two ways to solve the same problem. Let's take a step back and talk a little bit again about debouncing. Debouncing is one way of kind of implementing, I guess, a delay. So if you have a huge amount of requests coming in and you want to be able to handle that, debounce is one way to do it. And then the other way is throttling. Throttling is used for when you want to limit the rate at which a function is called. What we did here for this function, get autocomplete results, is we used a debounce value. We're basically saying if the value that the user has passed in hasn't changed for a certain amount of time, then we're going to use that value. What throttling does is it will call get autocomplete results every couple milliseconds or so. And so you can limit that to maybe like you want to make 2 function calls in 100 milliseconds or something like that. And that's what throttling is. It ensures that a function is not called more than a certain number of times within a given time period. When is that really good over debounce? Well, let's say you have a website where you want to keep track of mouse position. There's so much data that gets passed through when you're trying to keep track of mouse data. And so let's say you want to do an application that's a drawing application. So you want to keep track of the click, and then wherever the user moves, you want to draw like a pixel. So now if you want to draw all those pixels, it might be a little bit crazy because you're going to have thousands of pixels that the user is drawing in any given fraction of a second. But if you throttle those requests, let's say you only want to keep track of 5 or 10 mouse positions every second or so, you probably want more than that. But let's say you do that. Then what you can do is make an algorithm that will basically smooth out the points that you get back from your user's mouse position. So it's way better performance-wise to do that way. In this case, debouncing just happens to work better for this problem, but it's always good to bring up other solutions. So definitely talk about throttling and look it up if you want more information about it. So the other question that interviewers would ask in this scenario is, what if you search the same thing multiple times? So as you saw, I was constantly searching Barry. And even if I searched Barry before and I had the results for when I searched Barry before, it still makes this request to this function and still takes a little bit of time to show up. But the searches for Barry should be instant because we've already done it before and it's in the same browser session, so we should track this somewhere. You can talk about some form of in-memory cache that kind of keeps track of requests that you've made already. And if your request exists in this cache, it will just return the values in that cache versus calling the function or calling the fetch to get the same data again. The other thing that interviewers might bring up is what happens when there are no results for something. So if I type in a random assortment of strings and nothing actually shows up from my API, how would I handle that there's no results found? And also, how do I handle loading state? When I type in Barry, there's a little bit of a delay sometimes. How do I handle or show the user that the data is loading? And also error states. What happens when your API or this function errors out? Is there anything that you can show to the user when that happens? One last question the interviewer might ask is, how would you make this whole thing production ready? So I mentioned a couple of them. So show a loading state. You want to display a message when there's no results that are found. You want to handle errors. And a very important thing is you want to ensure accessibility. You want to make sure that this autocomplete component is accessible to screen readers and keyboard users. So things like adding proper ARIA attributes. Now, one way to fix this is to use component libraries that already have accessible components like an input component that you can build on top of. And those are very tested. You could find good ones to make sure that they're good. The other thing you want to do to make sure it's production ready is write tests. You want to test this component in different browsers. So you have Firefox, Safari, Chrome, Internet Explorer. And you want to test it with different inputs, different scenarios. Make sure that your input is sanitized. And the other thing you want to do as a proper front-end engineer, if you're building this into your component library, you want to document it and you want to make sure you document the props and different things that are being passed to it. So think about how you would generalize this component as well. All right, well, I hope you all liked this video. I am really exhausted. I was like, let me do one video a week for the rest of this year. And so this is the day before I'm supposed to post this. But I hope you all like this. I wrote this today. There's probably some mistakes in that, but please let me know in the comments and I'll do my best to correct those. And if there's anything else you want to talk about more in depth, let me know so I can make a video on that. So good luck with all your interviews if that's what you're watching this video for. Or I hope you're having a really good day. And if you like this type of content, be sure to subscribe. It'd be awesome if you all subscribe to me. I'm about to pass, I think, 4,500 people. So let's try and make it 5,000. Yeah. All right. Bye, everyone.